Hello, welcome to my YouTube channel. I'm Masika Michael, your chemistry revision master. I teach at Nasokol Girls in West Pokot County. Today, I want to take you through the topic of salts, and that is the preparation of insoluble salts. And I want just to give an overview is that insoluble salts can be prepared by either direct synthesis or double decomposition. And what I'm focusing on today is the preparation of insoluble salts by double decomposition or what we also call precipitation. And I have a question here that is going to lead us through that. And the question reads, starting with lead 2 carbonate, describe how lead 2 sulfate can be prepared in the laboratory. So we want to prepare lead sulfate. First of all, we need to ask ourselves, this lead sulfate consists of which parts? It consists of lead ions and sulfate ions, lead ions and sulfate ions. So which means to prepare this lead sulfate, lead 2 sulfate, which is an insoluble salt, we need a solution containing lead ions and sulfate ions. Now, a student could just rush into a conclusion that they can prepare lead carbonate, lead sulfate by getting lead carbonate with sulfuric acid. That method cannot work because when you react lead carbonate with dilute sulfuric acid, they will react to form lead sulfate, which is insoluble, and it will coat the lead carbonate, preventing further reaction. So you cannot prepare a lead sulfate by reacting lead carbonate with dilute sulfuric acid. So the only thing that we can do, we need to have a solution containing lead ions and a solution containing sulfate ions, so that when we react them, they are going to exchange ions and we get lead sulfate. So in this case, we cannot get a solution of lead ions by adding water to lead carbonate, because lead carbonate is insoluble in water. So the only thing that we can do, we shall react this lead carbonate with the dilute nitric acid, and when we react lead carbonate, lead 2 carbonate with dilute nitric acid, the products are lead nitrate solution, water, and carbon 4 oxide. So by so doing, we shall get a solution that contains lead ions, which is containing lead ions. Then after that, we can now react the resulting solution of lead nitrate with any soluble sulfate, so that now it gives out the sulfate ion. So that now, when you get a solution that contains lead ions like lead nitrate, and you react with a solution that contains sulfate ions like sodium sulfate, it's going to form insoluble lead sulfate, and it will be insoluble, and it can be removed from the solution, from the mixture by filtration. Now, that is why now to prepare lead sulfate, starting with lead carbonate, we shall use this procedure. We add excess lead carbonate to warm dilute nitric acid in a beaker and stir. So during this reaction, lead carbonate is going to react with dilute nitric acid to form lead nitrate, carbon 4 oxide, and water. Now, the next thing will be filter to obtain the filtrate, and the filtrate is now lead nitrate solution. But now the main reason for filtering is you are going to remove unreacted lead carbonate. But now the filtrate is what you want, is a lead nitrate solution. Then add sodium sulfate solution. Add sodium sulfate solution to the filtrate. Remember, the sodium sulfate solution is going to give out sulfate ions, and now the filtrate contains lead ions, so that when you react them, sodium nitrate, which is the filtrate with, lead nitrate, which is the filtrate with sodium sulfate, they are going to form sodium nitrate and lead sulfate solid. So you filter to obtain the residue, and that residue is now lead sulfate, and wash the residue with distilled water. That is to remove dissolved impurities, and then dry the residue by pressing it between filter papers. By so doing, that residue will be pure, a pure sample of lead sulfate. So that's just an example, one of the examples of the ways in which you can prepare an insoluble salt. Suppose now you have a different question, like let me just give you or show you another question so for further understanding. Like if you are provided with a solid zinc oxide and you also provided with solid sodium carbonate and dilute nitric acid and distilled water, then you have been asked to describe how the reagents provided above can be used to prepare a dry sample of zinc carbonate. Now, first of all, we need to ask ourselves this zinc carbonate that we have been asked to prepare, is it soluble or insoluble? Then we find that zinc carbonate is an insoluble salt. And because insoluble, we're going to use precipitation reaction. So we need to react a solution that contains zinc ions with a solution that contains carbonate ions to get zinc carbonate. Now, in this case, looking at the reagents provided, we only have zinc solid, zinc oxide solid. Now, zinc oxide, if we prepare a solution, if we want to prepare a solution with zinc oxide, if we add water to zinc oxide, if we add water to zinc oxide will not dissolve in water. So we cannot prepare a solution of containing zinc ions from zinc oxide by adding water. So that is why we are not going to use this dilute nitric acid. We react this dilute nitric acid with zinc oxide. Zinc oxide is a basic solution and nitric acid is an acid. So when you react them, zinc oxide is going to react as a base and dilute nitric acid as an acid so that they form a salt and water. And now when we react zinc oxide with dilute nitric acid, it's going to form zinc nitrate solution. Zinc forms zinc nitrate solution. And that is a solution that contains zinc ions. A solution that contains zinc ions, zinc nitrate solution. Now, we also have solid zinc, solid sodium carbonate. And this, from this sodium carbonate, we need carbonate ions. From this zinc oxide, we need zinc ions. So, this solid sodium carbonate, we also need to prepare a solution. And since sodium carbonate is soluble in water, we are going to dissolve that sodium carbonate in water to form a solution of sodium carbonate. So that now, when we react sodium carbonate solution with zinc nitrate solution, they are going to react to form zinc carbonate and sodium nitrate solution. And zinc carbonate formed is insoluble in water, so it can just be removed by filtration. It can be removed from that solution by filtration. That is now the complete answer for this question will be add excess zinc oxide to warm dilute nitric acid and stir. And here zinc oxide is going to react with dilute nitric acid to form the nitrate solution and water. Then filter to obtain zinc nitrate solution as a filtrate. As a filtrate, then that is what we are interested in because you want zinc ions. Then dissolve the solid sodium carbonate in distilled water to form a solution. Because from that solution we are going to get carbonate ions. Then add the sodium carbonate solution to the zinc nitrate filtrate. So that now when you do that, the zinc ions in the nitrate are going to react with the carbonate ions from the sodium carbonate solution to form a zinc carbonate solid and sodium nitrate solution. So you filter to obtain the residue, and this residue is now zinc carbonate. The residue is zinc carbonate. Wash the residue with distilled water. Remember, the residue is not going to dissolve in water because it is insoluble. So you wash the residue with distilled water, then dry the residue by pressing it between filter papers. In that reaction, zinc ions from zinc nitrate solution are going to react with carbonate ions from the sodium carbonate solution to form zinc carbonate solid, which is a residue. Suppose you have a different question. Of course, they are just related, but just to give you another example, that starting with the lead metal, describe how a dry sample of lead 2 chloride may be prepared. Now here you have a metal which is lead, and you have and they want you to prepare lead 2 chloride. A student can quickly think that because they want lead 2 chloride and I have lead, let me just react lead metal with dilute hydrochloric acid so that it gives me lead 2 chloride and hydrogen gas. Such a student should be reminded that uh, when you react dilute hydrochloric acid with lead metal, it's going to form lead 2 chloride, which is insoluble. So it's going to coat the lead metal, preventing further reaction. So we cannot use the method of reacting an acid with a metal because this lead 2 chloride is insoluble in water. So that's why we are still going to use the double decomposition or precipitation method. So the first thing that you are going to do is to prepare a solution that contains lead ions. And since you have lead metal, you react the lead metal with dilute nitric acid so that you get lead nitrate solution. That lead nitrate solution will be a solution containing lead ions and nitrate ions. Then you obtain another solution that contains chloride ions. So you get any solution, it could be a solution. That's it, to give examples like sodium chloride solution, magnesium chloride solution, zinc chloride solution, any solution that contains chloride ions. So that now when you react with the lead nitrate solution, the lead ions in the lead nitrate solution are going to react with the chloride ions from the soluble chloride to form an insoluble lead 2 chloride, which will now be obtained after filtration. That is why now the refined answer will be given as add excess lead metal to warm dilute nitric acid and stir. That is the first step. And step 2 will be filter to obtain lead nitrate solution as a filtrate. And now, remember, before we go ahead, when you react lead metal with dilute nitric acid, they are going to form lead nitrate solution, which contains lead ions. Then the reason as why you filter is to remove unreacted lead metal. Then add sodium chloride solution to the filtrate. Remember, from this sodium chloride solution, you are interested in chloride ions. From the lead nitrate solution, you are interested in the lead ions. So when you add lead nitrate solution to the sodium chloride solution, they are going to exchange ions. So that now it's going to form lead 2 chloride, which is insoluble, and that one will be formed, and the sodium nitrate will be soluble. So you filter to obtain lead chloride as the residue. But now it might be containing impurities. The next step will be wash the residue with distilled water, and finally dry the residue by pressing it between filter papers. And the ionic equation for that reaction will be lead ions coming from the nitrate solution will be reacting with chloride ions from the sodium chloride solution to form a lead chloride solid, which is now the salt that we are preparing. Remember to subscribe to my YouTube channel so that you can be notified when I upload the next video. Thank you.